started? Yep, let's start it. Okay. All right, well, thanks for coming to our data meeting today. Last we focused on cell organelle functions and increased mastery from 45% to 76%. That growth happened because we clearly identified the misconception and targeted it. Today, data shows 42% mastery on 8.6E, the most missed items, shown students understanding that part of the system changes mass, but they failed to apply conservation to the entire system. What actions did you take in your classroom before this assessment?
Before the assessment, we practiced measuring mass using our digital scales. We combined objects and calculated total masses, and then my students completed little practice experiments and scenarios. But yeah, essentially we just conducted the experiment after working on practice problems, and we practiced massing the objects and combining them.
Perfect. All right, well, today I'd like to focus, I would like for us to look at the standard 8.6E. The standard 8.6E investigated how mass is converted in chemical reactions and relate conservation of mass to the rearrangement of atoms using chemical equations, including the photosynthesis. The readiness standard, 42% mastery, and item number 17 was our most missed answer. Using your own words, what should a student know or be able to do to show mastery of this standard?
So for me, my students should know what the law of conservation of mass is as it pertains to 8.6E. They need to know atoms that are rearranged but not created or destroyed per the law. That's what the law of conservation of mass states. They need to know the differences between an open and closed system. And then lastly, they need to know chemical versus physical changes. All right. Now the action part, the do part, they need to measure mass accurately using their scales, calculate total system mass, so in a chemical equation, chemical formula, calculate the total, explain where the lost mass went, connect observations to particle rearrangement, so essentially counting atoms and whatnot, and then interpreting and writing balanced chemical equations.
Perfect. So we looked at a little no-show chart previously, and based on that chart, did you see anything that was missing? Did you have any ideas outside the scope of what we looked at?
I think the students needed to know to identify the chemical formula and whether or not the mass is increasing. Misconceptions, that they had was after the ring is dropped in a liquid, something changes, but what they will see is that it stays the same.
Exactly.
Yeah.
That's what we discussed. Let's review your teacher exemplar. What were the keys to an ideal student response? How does this align to the standard? And is there anything you would add to our chart to unpack the standard?
Yeah, so clearly separated the ring from the solution, and then combining the total mass, calculate before and after what masses were, use this language of conserve and all the TEKS vocabulary. I would want them to add, or want to add that to that as well. How is this aligned now to our standard? We have our investigations that we're required to do in science, data analysis, particle level reasoning, and then make those connections with the chemical equations as well.
Perfect.
Yeah.
So how does your student exemplar compare to your exemplar? Were there any gaps in that?
My teacher exemplar students should have been able to identify the ring's mass decreasing after it was in the solution. Some other friends, I also need to, as a teacher, know that students said solution mass increased, and then students incorrectly said total mass increase. So what were some misconceptions that maybe led to this error? I would say that there's a gap. They think that the solution and the ring combined will increase the mass at the end of the reaction. There's not another way to demonstrate mastery other than they need to know the law of conservation of mass. They, they need to make sure they solve it correctly, and then just essentially see that nothing changed.
All right, so looking at the samples of like the unmastered student work, and you've already kind of alluded towards this already.
Yeah.
What are some of the gaps you see in this unmastered student work? I know that it's going to include the mastery student work, but what are there other ones that these?
Yeah, for
students
the ones that aren't hitting the grade level mastery or the T mastery, is they're still getting confused between the part of the chemical equation and versus the total system mass, right? So the total at the end of the product. They have this belief that a new substance, if you get a new substance, that the mass is going to increase, which is a misconception. They fail to identify system boundaries, and then they don't apply the law of conservation of mass correctly. So that's what I've been seeing in the gaps for students that aren't mastering this TEAC.
All right, so let's see here. Let's take a look at a little bit of the errors. Let's look at a reteach real quick. This won't really take too long, even though we might have to spend a little bit of time kind of looking at it real quick. Let's look at the student mastery and how they can improve, and also keep in mind the areas that are people that aren't currently at mastery.
All right, so I would say we could write this on our chart. Let's record this on our chart using the words. Student mastery would improve if students systematically conducted the experiment. Student mastery will increase if understanding of key vocabulary, and then student mastery will increase if they write out chemical formulas seeing where they are equal.
That's perfect. All right, so let's talk about how the reteach will look. So we're going to talk about the reteach structure real quick. Should we use a modeling or a guided discourse? And what tasks should we make sure that we implement before we plan our reteach, and think about what the students are thinking about while we're planning this.
Yeah, so when students fully understand this concept, what I'm expecting them to be able to say is the ring lost mass because atoms moved into the solution, they rearranged. The solution gained mass, the total mass stayed constant, atoms rearranged, none were destroyed, and then in this closed system, the chemical formula and the mass remains constant.
All right, that's a perfect answer. And then if we are continuing on the right here, let's check out this no-show area about the modeling.
Yes, the modeling.
So talk to me about how you had modeled this experiment.
Yeah, so it's just like when you conduct any experiment, right? I'm going to lay out the steps. First, we'll mask the ring, right? They'll measure it on their scale. Secondly, I will mask the beaker and liquid solution. All right. Then I will place the ring in the solution. I'll let it sit for about 15 minutes. Take the ring out. I will now mask the ring and explain where this misconception occurred, right? Like, why did the mass decrease whenever particles, flakes came off? The seventh step, I will mask the beaker and solution and explain the misconception if there is a change, right? There is going to be extra particles floating in the solution, so we can expect the mass to increase. And then lastly, I will put the ring back in the solution and get the final mass and explain how the law of conservation of mass is demonstrated in this experiment.
That's perfect. So when we're planning this reteach, and you've gone through this modeling, and this is essentially modeling the experiment and going through each of these things, let's compare our reteach plans, and what do you notice, and what can we pull from each to make our plan the strongest plan?
Right. So I would want them to have an independent practice. All right. So I would want them to conduct investigation with data table and using claim evidence reasoning. I will monitor to see if they're doing it correctly. What laps will you name? right? So the first lap, I will monitor to see if the scales are being accurately utilized. And then my second lap, I want to see them being able to record correctly the masses and grams on their lab sheet. And then third, are they adding up at the very end their product? Is it equal on both sides?
All right, that's awesome. And that kind of like puts us at that practice stage. So right here, if we were to practice, and that's
Yeah.
kind of what you essentially just talked to me about. Are there any things different that we want to like look at as far as a practice? Do we want to ask the students anything different, or
Right.
in addition to our laps?
Yeah, so no, essentially just make sure those 3 laps, are they accurately using the scales? Are they recording correctly? Is their addition correct? And then at the end, ask students, did what made this experience more effective, right? Was it the hands-on? Was it, just going back over and reteaching it? And so, letting them know, lock it in, and let's take 2 minutes to finalize our, reteach with
Sure.
the kiddos.
That's perfect. So, and did you have a day that you were planning to do this reteach?
Yeah, I was thinking Wednesday during my first, second, fourth, sixth, and seventh periods, just so all my classes just to, reteach, spiral this 8.6 back. And so not only just reteaching, but making sure that at the end of class they get an exit ticket, that, I can monitor the growth, right? That they went from a 38 up to a 70.
Sure.
And just, we'll review how they do, and then let the kids know how they do the next day on Thursday.
All right, that sounds like a great plan. Thank you so much for
Yeah,
your time
no
today.
problem. All right.
Take the hand, shake hand. That's amazing.